Welcome to Kopernik Observatory and Science Center. My name is Drew Desker. I'm the director here at Kopernik, and I'm really excited about what we're about to do today. And it's actually something we've done a number of times with our summer camps, but I get nervous every time we do. I literally, if you want to zoom in here, I've got goosebumps. So again, Kopernik has been around now. We're celebrating our 50th year as a public observatory and STEM education, informal STEM education facility in the area. And for over, this is now I think our 32nd year offering summer camps that have a STEM focus. And for the past, going on almost a decade now, we've been able to have an opportunity to have our students talk to an astronaut as they're flying by on the ISS using some ham radio equipment, and we'll sort of get into that. So again, just to back up a little bit, our summer camps start as young as rising second graders, all the way through high school. They are week-long camps that start on Monday and on Friday, go from 9 to 3. And we do a wide range of topics for the week, and we really focus on hands-on activities and an opportunity for the students to really dig into the science or the technology, and hopefully stir their curiosity on how things work, and then maybe at some point plant a seed for turning into an interest or some curiosity into a STEM career. And if you allow me, one of the camps one of the programs that we've run here is called Girl Power Science, and it's an opportunity for girls, usually between 3rd and 8th grade, that will come up here and learn about some topic of some sort. And we always have a female subject matter expert talk about what work she does in the particular field. And so, because it's always a video conference, our girls get to ask her questions. And a few years ago, we had an astrophysicist from the Goddard Space Flight Center down in Greenbelt, Maryland, talk about the work that she does using satellites and how they collect data with respect to carbon dioxide levels and how that affects global warming and all that other stuff. And then during the question and answer period, one of our girls asked, "How did you get interested in astrophysics?" Again, these are 3rd to 8th graders. And her answer was great. She says, "Well, when I was in college, I was an English major, but my boyfriend was a physics major. And we'd go from observatory to observatory. I eventually dumped the boyfriend, but I kept the astronomy." Now she has her PhD in astrophysics and works for NASA. So we never know where a seed's going to get planted. And so that's really what we're all about. So in the camp, we actually are running 2 camps this week. We are running the Welcome Aboard the ISS camp, but also we're running another camp called Secrets of Code. These are rising 3rd and 4th graders that learning about all sorts of code, everything from QR codes to Braille to Morse code to code programming that they'll get through toward the end of the week. So it's an opportunity again for them to dig in. So, but our ISS camp, we've covered a lot of topics already, and we're only halfway through. In preparation for this event this afternoon, we wanted to make sure that they understood what was going on. So one of the first things we learned about was satellite orbits. And so if you look here up on the screen, we are showing this map, Mercator projection of the map. And I'll get a little deeper into this in a moment, but talking about why does these dots represent what we call the sub-satellite point of this case the ISS. Why is it making a turn when it gets up toward Labrador? And so the kids figured out how that was, why that was. We talked about radio communication and why we have to use special equipment to talk to the ISS. Later this week, they actually got started on it today, but they're going to be making an antenna that is actually this kind of an antenna, believe it or not. With the right conditions, I could use my little walkie-talkie, I could use this antenna, and I could talk to the astronauts using just this. And so our students will actually do that. So again, we talked about, I talked about that we're using ham radio to do this. And ham radio is it's licensed by the Federal Communication Commission. You actually have to take a test to show that you have some knowledge, basic knowledge of electronics, of operating skills, of safety. And so you have to sit for the test and you have to pass the test. But once you pass the test, then you get a ham radio call sign. So my ham radio call sign is KA1M. I got licensed when I was 12 years old. Well, we got somebody here who beat me by 2 years. So Jackson Peck, who is one of our students in the class, when he learned about this camp and an opportunity to get his ham radio license, both he and his mom studied together and passed it the first time. And so Jackson is going to be our, what we call the control operator, because you need a licensed ham radio operator to actually press the transmit button. But then our students will get a chance to talk over the radio. So so congratulations to Jackson. Actually, this technically will be his first real ham radio contact. So I hate to disappoint you, but the rest probably won't be quite as exciting. But it's still a lot of fun. Again, I've had my ham license since I was 12. And it's been a great opportunity for me to learn. I've met some great people. And I get to do things like this. So what I want to do now is actually going to play a couple of videos for you here to give you a sense of a little bit both from the astronauts' point of view, but also from people on the ground's point of view of what this contact will be like. So I'm going to go to, is it this one? Yeah, it's Tim Peake. Here we go.
NA1SS, this is N2SJ, over.
NA2SJ from NA1SS for scheduled contact.
Hi everyone, I'm Tim Peake and welcome aboard the International Space Station, where we're orbiting Earth 16 times every day. One of the most rewarding activities that some astronauts undertake on orbit is to talk to schools using the space station's ham radio. Now these are events that are planned by ARIS, which is a worldwide group of amateur radio volunteers who are dedicated to introducing young people and students to science, technology, engineering and mathematics. Now this is the equipment here in the Columbus Laboratory, which consists of a handheld radio, a headset, and we also have a ham video unit. Now as the International Space Station orbits above your location, a radio link is established between the ISS and your school. Now because we're travelling at nearly 18,000 miles per hour, which is an incredible 25 times the speed of sound, we usually get about 9 or 10 minutes of good radio contact before losing the signal. So about 5 minutes before the scheduled start time of the contact, I come into the Columbus Laboratory and configure the radio so that I'm on the correct channel. And sometimes I'll set up the ham video too. Just before the predicted time, I'll begin to start calling the school using the standard amateur radio calling techniques. For example, if the call sign of your school was GB4 Fun, I would say Golf Bravo 4, Foxtrot Uniform November. This is Golf Bravo 1 Sierra Sierra, listening and standing by. Now at your school, the radio operator will be listening for my call, but may also transmit and try to call me as well. You'll probably have a much more powerful transmitter on the ground than we have up here on board, so I'm likely to hear you before you hear me. Then, once we can hear each other, then comes the best bit, which is actually talking to the students and answering the questions. Once I've answered all the questions, we use the remaining time to say goodbye to each other and end the connection. I'll then spend a few minutes configuring the radio back into a rebroadcast mode, and then I'll go back to my day job, which is of course doing science on board the International Space Station. ARIS is a brilliant opportunity for astronauts to talk to school pupils. It's really rewarding to hear how excited the students are when they're talking to somebody up here in space. And it's a true privilege to be able to inspire our next generation of scientists and engineers through amateur radio.
One of the things that our students in our camp learned was about some of the astronauts that are actually aboard the ISS. There are currently 9 astronauts living and working on the International Space Station, 4 of which came up on a SpaceX Crew Dragon, 3 of which came up on a Soyuz capsule, and 2 that came up on the Starliner that's currently docked, and this is on its maiden voyage, and they're just still doing some checkout on what it's going to take to make sure that the spacecraft is ready to return with Butch and Sonny. But 2 of the astronauts, one of which is actually an astronaut from Syracuse, New York, Jeanette Epps. And there's another one that called Matthew Dominick. These are both first-time flyers. And so they both had made some small, quick videos about why, what going to space means to them. And so I'm going to play both Matthew and then Jeanette. At this point, again, we don't know who we're going to get for an astronaut. So we'll for our talks. But let's see how we do here.
For an inflection point that I feel is coming. If you look at the history of civilization and various inflection points, things just kind of take off. I am NASA astronaut Matthew Dominick, commander, NASA's SpaceX Crew 8 mission to the International Space Station. I grew up in Wheat Ridge, Colorado. I was the oldest of 2 brothers. I had 2 parents that were amazing in that they encouraged my curiosity. Growing up there in the Rockies and the outdoors, there were so many things to go and do and see. I've always wanted to explore and satiate my curiosity for the world around me. And so I just kept pushing throughout my life. I joined the Navy because I wanted to fly airplanes, I wanted to go fast, I wanted to test airplanes. And so astronaut for me was just the next logical step in life to keep going and keep exploring and keep pushing myself further in terms of intellectual curiosity about the world around me. I've been at NASA now for about 6 years, and I'm super excited to fly in space. Working and training with Crew 8 is absolutely awesome. We have a diverse group of academic and intellectual backgrounds that come together, and also an international component. It is such a blast to watch the crew grow as we started training over time, to watch that team dynamics develop as we get ready to launch. We're starting to see what makes each other tick, what's important to each other. I view Crew 8 like an Olympic torchbearer. That's where I see Crew 8. We are a torchbearer on that path to the Olympics that are going to occur in the future as we move humanity forward. We're going up there to relieve Crew 7, Crew 9 will relieve us, and we are keeping the flame of space, human presence in low Earth orbit, alive. If you're a studier of science or statistics, you know that you always want to have a big N, and that just means sample size, to understand the thing you're studying. So just launching 1 or 2 or 10 or 15 people to space leaves you with a very small sample size. So every time we launch 4 more people to space, we're building our sample size and our understanding of the human body and the things that happen to it in a zero-gravity environment. That sets us up to go to the moon. It sets us up to go to Mars. Many folks think of NASA and they think we're using crazy cutting-edge technology and all kinds of adjectives and superlatives to make space work. There's no smoke and mirrors, there's no magic. It is just hard work through the laws of physics and basic material science to get us into orbit. That's the magic. We are part of a massive team of people that need to continue continuous human presence in low Earth orbit and not letting that flame go out. We are line soldiers on the ground marching to make sure that this continues. And just being a small part of that and continuing that is what's important.
Now we're going to meet Jeanette Epps. You actually saw Jeanette in some of that video in Matthew's Matthew's video. And Jeanette has been here. She was down here in actually 2014. We'll let her speak for herself.
What I love about space exploration is finding out new things, learning new things we never thought we would learn in my lifetime. My name is Jeanette Epps. I am a mission specialist for the NASA SpaceX Crew 8 mission to the International Space Station. I am from Syracuse, New York, where it's very cold. I am one of 7 children. My twin sister, Janet, yes, Janet and Jeanette, we both loved science as kids. Janet went on to become a molecular cell biologist, and I became an aerospace engineer. I think I always secretly wanted to become an astronaut. I just never thought that it was something that was obtainable. In 2008, a friend of mine, Leland Melvin, called me and said that they were accepting applications for the next class. I thought it was my last chance to apply, and so I did. June 2009, I received a phone call from Peggy Whitson, and she asked if I wanted to join the astronaut corps. It was very overwhelming and emotional for me to actually get that call and be selected. Prior to coming to NASA, I worked for Ford Motor Company, and then I went on to work for the Central Intelligence Agency. At both of those places, I learned to be very deep in technical matters, but then also how to become operational. Our mission will entail getting on the vehicle, flying to the space station, taking care of the International Space Station, and then we'll also conduct experiments. Each individual will be an experiment in and of themselves, how our cells behave, how our blood changes, how our bone density changes, muscle mass. We're looking at everything to figure out countermeasures for the human body so that it can live longer and longer outside the Earth's protection. Not only will we be an experiment, but we'll have other experiments on board that we'll conduct. The experiments that we conduct hopefully will get the human body and other things to the moon, and then from the moon to Mars. I will be the GEM specialist, which is the Japanese experiment module. I may get a chance to operate their robotic arm to help them with experiments that they'll do outside of the space station. Since this will be my first trip to the International Space Station, I'm looking forward to viewing the Earth from an amazing vantage point, but also experiencing all the nuances that go along with that. As we walk to the launch pad, as we're strapped into the vehicle, the things that I believe I'll be feeling: unbelief, surrealism, but also joy. And then once we go into orbit, just to see the Earth from that vantage point, and then thinking of ways that we're gonna work on the space station that's gonna help our home that we're now untethered to. When I get to the space station, I'm expecting that it will be like home. We've trained so much here on Earth in the mock-up that looks just like the International Space Station. The biggest thing I'll have to do is adapt to space during the first 2 weeks of being there, and then I'll settle into home.
All right, so you've met at least two of the 9 that are on the ISS. Actually, I'm going to take a break here and just also welcome those watching on the live stream. Kopernik has its own YouTube channel, and every Friday night we live stream our programs. But when we have special events like an eclipse or a meteor shower or something, or talking to astronauts on the ISS, we are live streaming. So I'd like to say hello to everyone watching on the live stream. And I'm gonna, hi Mom, hi Dad, exactly. So I'm going to do one more video. Well, I've got 2 more videos here, but this next one is actually another group that have had an opportunity to talk to the ISS and what it means to them. So let me go to that. Oops, that's not the one I wanted yet. This one.
I grew up out in the country in Indiana. Corn and soybeans were the main crops. I had always been interested in technology and in science. Being out in the rural setting, there wasn't a whole lot of support for this. Space Jam is an annual weekend Boy Scout event, and we do all kinds of technology-based things. We have about 1,000 people that come every year. This is our 7th year doing it, and it's a blast every year. The contact with the International Space Station was one of the driving forces that helped to create Space Jam. In fact, the first Space Jam was really basically only about the contact.
It was a dream of the ham radio operator to say, hey, I want to talk to the astronauts on the space station. How cool could that be? That's the top of the game.
Each year we call up the International Space Station and we give these young kids the opportunity to ask questions to the astronaut.
Is it true that it will take over a year to get to Mars and back over?
It absolutely is true.
The first time that I remember really having this real impression was, I think the 3rd year we did this. I was in charge of actually calling up the space station and establishing the contact. We were out in the middle of the night in a field, and I said, NA1SS, NA1SS, this is WB9SA, calling for a scheduled contact. Do you copy, over? And I said it again, and all of a sudden, real crisp comes back, WV9SA, this is the International Space Station. How are you doing tonight? And we're like, oh, this is amazing. I graduated as valedictorian, and I was lucky enough to be admitted to Princeton with a complete scholarship, and I then moved to San Francisco where I'm a software engineer. So I went from living on a farm to living downtown in San Francisco writing software for people. It was a really amazing experience to do all that.
All right, and finally I got one more video that I'm going to play here that is put together by ARIS. ARIS is a nonprofit corporation called the Amateur Radio on the ISS, and they are the ones that really make this happen.
Hi, my name is Ruth. And my name is Chris. You must be pretty excited to talk directly with astronauts on the International Space Station today. While we're waiting for the space station to come over your portion of the sky, let's talk a little bit about how it's going to happen. Of course, Mission Control is in contact with astronauts all the time, using a big radio with lots of fancy equipment.
However, we're going to be using something very different today. We are going to use ham or amateur radio to talk directly to the International Space Station.
When most people hear the word radio, they think of a music radio station. But it's so much more than that. Radio actually refers to the unseen energy that transmits all sorts of signals using electromagnetic waves. At first, people learned how to send signals like Morse code. And then they discovered that you can send so much more, like data, computer signals, and even TV.
Maybe you don't realize it, but you use radio every day. Maybe you watched the TV this morning, or you texted your friends, or maybe even you check social media like Twitter or Instagram.
Let's travel back to space for a minute. Since the beginning of the space age, humans have sent many spacecraft out into the universe. These range from the Hubble Space Telescope orbiting the Earth daily, and the Curiosity rover exploring Mars. We've even sent a long-distance messenger, the Voyager 1, who has traveled outside of our solar system.
Whether it's capturing a great picture of a far-off galaxy or conducting experiments on the space station, radio has to do with all of these. And today, you're going to be using ham radio. Now you might be wondering, what exactly is ham radio?
Amateur or ham radio is a service and a hobby where operators can talk with people around their neighborhoods, their cities, their country, and even around the world. Amateur radio operators require a radio license from the government. They're not that hard to get. I have one. My call sign is KM4LAO.
And mine is KD8YVJ. Our call signs are a way of identifying who we are to other operators. This lets everyone know that we have the proper license to using the radios.
As amateur radio operators, or hams as we are often called, we can talk with others about basically whatever we want, often science or some new radio gadget that we are interested in.
Let's focus back to the space station and your contact today. Many of the astronauts and cosmonauts aboard the space station are licensed ham radio operators. That's why your operators today can contact them. The people here, as well as the astronauts, are licensed to talk to each other, and you are allowed to talk over to their radio.
For our conversation today, we'll need an amateur radio station on the ground, either in this location or somewhere else around the world. We'll also need a radio in the space station.
Anyone SS, anyone SS.
You can hear the calls coming. This is November Alpha 1 Sierra Sierra, the International Space Station, over.
On the space station, the radio transceiver is connected to an amateur radio antenna mounted on the outside. One of these antennas will be used today during our contact.
For our side of the contact, we need a good-sized antenna, a signal amplifier, something to make our signal stronger, and a rotator for turning our antenna. We have to keep our antenna pointed right at the International Space Station. And remember, it's moving across the sky and fast.
To aim the antenna properly, we need to track the path of the space station exactly. NASA uses complex systems to track the path of the space station and other orbiting objects.
The satellite tracking program we are using works out a complicated set of mathematics to provide the orbital location of the space station moment by moment as it moves through space. This information is sent into the computer that controls the antenna rotator, which moves the antenna to follow the space station. Maybe some of you have seen or worked with robotics. That's pretty cool stuff. And just like you can program a robot where to go, what to do, and how to get there, you can also program a computer to tell an antenna how to track the space station across the sky.
You know, it took a lot of planning to get this contact. Several weeks ago, the ARIS operations team had to figure out when the space station's orbit would pass over this location. Then, they had to talk with the planners at NASA's Johnson Space Center. The crew's time is pretty full, so they were able to find a time that could work for the crew members' schedules. Once they found times that would work both in space and here on the ground, the host organized this contact. And in just a few minutes, you'll be hearing and talking to the astronauts.
Well, it's almost time for your contact. It will be exciting, so good luck with it.
All right, well, you saw Ruth, and I didn't catch the other, what was his name? Chris. Well, guess what? Guess who we have here? We have Ruth.
I grew up a little. Yes.
Introduce yourself and talk a little bit about what you do.
Yeah. Hey everyone, I'm Ruth Campolio. Yeah, I got to be a part of that video several years ago now. It was such a great experience for me. That was even before I'd been able to do an ARIS contact of my own. I got to learn about how it all worked and be a part of contacts and then get to talk with them myself later on. So yeah, I am a grad student at Penn State. I am going for my PhD in acoustics, and I work with Youth on the Air summer camp, and we're trying to do an ARIS contact direct. So I found that they had a live contact here, so I went ahead and came up to meet everybody and see what was happening here and get a good experience for our hopeful contact next summer. So yeah, it's great being here and having a lot of fun, and good luck.
All right, thanks, Ruth. All right, so what I'm going to do now is explain what we've got here on the screen, at least those that are watching here at Kopernik. On the right-hand side, you'll see this is actually a NASA TV, direct live from the ISS. But over on the left-hand side, there is a big map. And this is the software that we're using. We have a radio that's actually in the observatory that we've got an electronic connection to for our audio. But this is exactly the software that we're using. And so if I go here, I can zoom right in. And this is the current location of the International Space Station. It's just about crossing the Yucatan Peninsula to cross into Mexico. And those dots are the path that it's going to take. This little X right up here, that's us. Now, as do you remember, students, my camp, what is that big white disk? It is the satellite footprint. Satellite footprint. That's how much of the Earth that the satellite can see. So when this white disk gets to be where we are, that's when we have the opportunity to actually talk to the astronaut. So up here also, it's going to be a little hard to see. This is unfortunately as big as I can make the screen. But there's some data here that is of note. So there's an azimuth reading, which is what north, south, east, or west do we have to aim our antennas. So in this case, it wants to aim it at 246 degrees, so it's to the southwest of us. Right now, it's negative 9.6 degrees of elevation, so it's below the horizon. When it gets to be above the horizon, that's when we should be able to start communicating with the astronaut. And you'll throughout that contact, if you happen to look at those numbers, you'll see them constantly be changing. This height is actually in kilometers, so it's 217 kilometers, and so that's basically about 250, 260 miles high. Actually, what they had to do this morning was a boost. So this morning they had to actually fire some rockets on either the Soyuz or the SpaceX capsule to actually boost the orbit of the ISS because it's constantly trying to fall back into the Earth. And so right now here they talk about AOS at, that's not quite right, but our AOS should be at 1417. So we are about 3 minutes away, and so what's going to happen is before because the boost went up higher, and we don't know for sure exactly where the ISS is, we have a general sense of where it is, we're going to actually have Jackson start calling a little bit earlier before we see that white disk cover our location. So that, and then we'll give a pause, wait for them to call back, call back until we finally make that connection. Then our students are going to get in line. So I'd actually ask our Director of Education, Dr. Laura Lamish, to get our students lined up in line, if you would, just like we did during the rehearsal. Right now? Yeah, right now, yeah. And once Jackson makes the contact, he actually has the first question, so he'll be asking the first question. You'll note that every one of our students will say over, and that's the cue to Jackson to stop the transmit button, and the cue to the astronaut to start answering the question. And we've had help from the Binghamton Amateur Radio Association. It's a group of ham radio operators that also operate out of the Kopernik Observatory that helped me do this kind of work and work through some of the bugs and get all the equipment all set up for us. So again, we have a very strict time frame. We can only talk to it when it's above the horizon. So we are going to, we actually practice the choreography of having the student ask the question, then that student's going to get out of the way so that the next student can be ready to talk. So you know what? I think we're pretty close to where we need to be, so I'd say let's go and give this a shot.
November Alpha 1 Sierra Sierra, this is Kilo 2 Zulu Romeo Oscar. Do you copy? Over. November Alpha 1 Sierra. Oh.
Louder.
Sierra Sierra, this is Kilo 2 Zulu Romeo Oscar. Do you copy? Over. November Alpha 1 Sierra Sierra, this is Kilo 2 Zulu Romeo Oscar. Do you copy? Over.
One more time.
November Alpha 1 Sierra Sierra, this is Kilo 2 Zulu Romeo Oscar. Do you copy? Over.
2 Zulu Romeo Oscar NA1SS, loud and clear. How do you pound me?
Okay, go ahead.
Welcome back to Kopernik Observatory and Science Center. Here is our first question.
Go ahead.
This is Jackson. How does the training underwater compare to the feeling of weightlessness in space? Does it actually feel pretty similar? Over.
Quite the same. When you're sitting in your spacesuit underwater, when we are training, you can feel your body sitting on the bottom of the suit, but it's pretty doggone close. It's great training for us here in space. Over.
Stanley now.
This is Stanley. Looking out to space from the ISS, in what ways does it look different from a night sky on Earth? Over.
Oh, man. It is so beautiful, Stanley. I can't even tell you. I've been trying to take pictures. I've taken over 100,000, 200,000 images trying to capture the beauty of looking out the window. You can see the horizon. You can see the atmosphere. You can see stars. It's just really, really beautiful. It is going by really fast. It would take me days to explain how beautiful it is looking out the window. Over.
This is Kata. Is artificial gravity just science fiction or a possibility in the future? Over.
Again.
Really have to convince me that something's not possible. So maybe it is, but right now, and I think for a long, long time, and probably forever, artificial gravity is just science fiction. Over.
This is Andy. Does the ISS have any engine powering it forward? Over.
The ISS does have an engine on the back of the spaceship. We use that, but we don't burn. It's not burning all the time. Our big solar arrays and space stations have a little bit of drag on them because there is a little teeny tiny bit of atmosphere up here, and that does slow us down. So every now and then, like today, we fired our engines for a couple minutes to accelerate us. And for a moment here, Andy, I am going to go back to the previous question, artificial gravity, because I thought initially you said anti-gravity. It's artificial gravity. So there is artificial gravity, and we can spin space stations in the future. That's not too far away. So artificial gravity would be spinning a space station and simulating gravity with centrifugal force. But anti-gravity is not the case. Science fiction. Artificial gravity is possible through spinning. Over.
This is Alden. How did they keep the ISS in orbit before there were astronauts on it and in between missions? Over.
Space station has had people on it for over 20 years without a single break. We've been continuous. Now, before people were on board the space station, computers and the ground controlled the space station, which is still true today. All the flying of the space station, 99.99% of the time, is done by mission control. The astronauts are up here, and we are doing science and experiments and research and fixing the space station. But the space station is flown by the ground. Over.
This is Dennis. If the sun is the center of our solar system and gives heat and light to the other planets, why is space cold and dark and not bright and hot? Over.
Well, temperature is a measure of the average kinetic energy of particles in a piece of matter. So for something to be hot or to be cold, it has to have mass and take up space, which is the definition of matter. So the space between the sun and Earth, or sun and Mercury, or sun and Jupiter, if it's a vacuum and there's no matter there, it's not going to be hot or cold for that matter. So to have a temperature, you need to have mass. The sun transmits its energy via waves, in the electromagnetic spectrum, to the planets in the solar system, and once those waves arrive, they warm up matter. Over.
This is Abigail. What does a sunrise look like on the ISS? Over.
Sunrise is gorgeous, and it happens real fast because we're moving really fast. We're moving 17,500 miles an hour towards the sunrise. So we make the sun come up real fast. I think something on the order of a sunrise takes about 8 seconds up here. But it's absolutely beautiful, and the colors go from this light blue to blazing orange, and it's absolutely amazing to watch. Over.
This is Abby. What does space sound like? Over.
Sound waves need a medium to transport food. So sound waves need to oscillate air particles, or sound waves need to oscillate solids or liquids to transmit audio. Like dolphins are in the water, and dolphins can make noises because it travels to the water. Sound waves do not travel unless they can go through mass. And so in space, if you're talking about a vacuum, sound does not travel in space at all. There's no noise transmitted whatsoever. Over.
Hi, this is Henry. How long was your training for this ISS mission? Over.
Training to fly an ISS formally started about 7 years ago for me when I joined NASA. But informally, it started when I was your age. You have to, right now, you want to start looking and being curious about the world around you and discovering things and learning things and doing well in school. That's when your training starts, and going to school and learning all of the time. Over.
This is Olive. What does it feel like to experience a rocket launch? Over.
One word, incredible. One word, laying on your back, that initial lift off when they count down to 0, you just feel like you're lifted up, like somebody's got their arms underneath you and just lifting you up and throwing you up into the air. But it just doesn't stop. They're just constantly lifting. It's really, really incredible experience. I will never forget just that uplifting feeling of this giant rocket just lifting you off the ground. It's absolutely incredible. Over.
This is Allison. What was your inspiration to want to become an astronaut? Over.
I've wanted to do so many things in my life, but I've always wanted to go faster and farther and explore and understand the universe around us, and what a better job to do it than this. Over.
This is Angela. What is the most challenging thing you have encountered as an astronaut on the ISS? Did you create a solution or overcome it? Over.
I'm going to tell you a little secret weapon, personal weapon for the rest of your life, and it's just called discipline. The most challenging thing we do up here is discipline. So I have to get up and work out every single day, and take care of the basics every single day, and study every single day. And so getting up and doing the same thing, or getting on a bicycle every day and staring at the same spot on the wall, takes a fair bit of discipline and desire, and you get up and you do it. That is true for just about everything in life. So secret weapon, discipline. Over.
This is Carson. How do you get enough air on the International Space Station? Over.
Step one is to make sure we're not leaking. So we have lots of seals around here to keep the air in. And as our body breathes in oxygen, it puts out carbon dioxide, CO2. And we have machines that scrub that CO2 and give us back the oxygen. So we tend to keep our oxygen on board and process it here. And so we use the energy of the sun to drive the solar arrays. The solar arrays charge the batteries. The batteries run the electrical devices that scrub the carbon dioxide out of our air and put back into oxygen for us. So ideally, we keep it all here. Of course, everything's a little bit leaky. So we do launch more air up to the space station for us. But we pretty much just keep it and keep reusing it. Over.
This is Charlotte. In space, do you eat all your food from a bag?
Over.
Most of our food comes in bags. We have a wide variety of foods. Some of it is hydrated, which means it's already got the water in it. Some of it's dehydrated, which means we have to hook it up to a machine and pump water into it and let it rehydrate. But yes, all of our food comes in a bag. We can't eat things like bread or chips because it makes crumbs, it makes a giant mess, and they just float everywhere. But pretty much everything comes in a bag. Over.
This is Olive asking for Cece. Can I go to space? Over.
Great question, and that's exactly what we're trying to do. Governments around the world have worked together to put humans into what we call low Earth orbit, or orbiting the Earth. And right now we're opening that up to the rest of the world and trying to get as many people as possible to come to space with us as we move the frontier forward. NASA and other governments are working together now to take us to the moon, while commercial programs come in and take over low Earth orbit. So yes, come join us in space. Over.
This is Steven. Is it hard or easy to pick up things in the vacuum of space? Over.
Things in space, up here, well, the vacuum of space outside doesn't really matter, just as long as you got a spacesuit on. So either inside the space station or outside where there's no air, picking up and moving things isn't too big of a deal because they're weightless, but they still have mass, so you have to push them. But I'll tell you, it's a lot of fun. One of my favorite things to do up here is grab one of my crewmates and push them through the crew module. So I can grab one of my crewmates, another adult human, and push them, and I can push them the whole length of the space station. It's pretty awesome. Over.
This is Aiden. What is the greatest danger on your mission? Over.
I believe we may have lost us at this point.
It is 14:28.
Okay. You can do your final one here.
November Alpha 1 Sierra Sierra. This is Kilo 2 Zulu Romeo Oscar. Thank you and over.
All right. All right. Well, we had explained that this, in fact, could have happened. That depending on how long of an answer a student had, the astronaut had, we may not have been able to get to all the questions. So I apologize to those last few students that did not get a chance to do this. But on the other hand, the audio quality was fantastic. That in fact was Matthew Dominick. That was that first astronaut that we met on the video. So at this point, we do have some media here, so that if people want to have an opportunity to talk to the media, we can do that. I thank you very much for coming up here to be part of this. It was, it's been very exciting, especially since it worked. And we look forward to having your students back for the last couple of days. And we'll, at this point, for those parents that came up here for the camp, if you wanted to take your child home today, I mean, at this point, you're free to do that. But otherwise, we'll certainly keep them until it's time to go otherwise. So, and I also want to thank the Secrets of Code Camp for coming and being part of this. And we try to do this every other year. So who knows? Maybe in 2 years, if we're doing this again, you can be the ones up here doing that work. So thanks again. All right. Yeah, can we get a group photo of the entire group here, please?
Before you do that,
What?
let me just take
Oh,
my
sure. Okay.
this way.
Give them a second. My students, can you go back to your chairs?
There, we can just avoid the scene outside.
Yeah.